Welcome to my short video on power supplies. So a power supply sits in a computer and it provides power to the computer. Um, in essence, it makes things happen. Now, my first question there is what is a power supply to do? There are some fancy explanations, but I'll put it this way. There are two types of current. There's AC and DC. AC current is an off on off on off on off on current. And they do that which allows them to extend the range they can transmit that power, and it also provides a more safe form of power because there's a moment off which you can actually let go if you're hooked on. Now DC is direct current. Direct current is on all the time. It's like a battery. Now, computers don't do well if the power comes on and off and on and off and on and off. It's very problematic. So, what a power supply does is actually converts our AC power to DC power, which is good for the computer because it's continuous. Now, so its real purpose is to convert AC to DC, and there are varying types of power supply. Now, my second question, I'll kind of go to a little bit of a presentation here slide wise. So, the way it works this is that conversion is it brings that AC power and it basically maneuvers and stores it until it can create a continuous stream of power, that direct current. Now, why should you never open a power unit? Because that internal part of the power supply can actually retain power for a very lengthy time in excess of days. So opening that power supply and accidentally hitting something in there can get you electrocuted. So it presents a danger hazard. So when it comes to power supplies, don't open them. That's pretty simple as that. So what determines the requirements of your computer or your power supply? It is actually the components installed inside your power. So first of all, that is the simplest one, and we're going to work on that in a moment. So your components need a certain amount of power. If your power supply cannot meet that requirement, what your computer will do is it will smartly start shutting things off. One of the biggest complaints people have is they'll say, I bought a new graphics processor, but I turned it on and nothing happened. A lot of times when you look at that, you'll find that the power supply wasn't big enough to actually provide power to the graphic card. That graphic card was just too much. So the computer just said, ignore the graphic card, provide standard graphics. And that was as simple as it went. Now, what really determines those requirements is a couple other things too. One, the case configuration. Large cases can hold some really big power supplies. As our computers get smaller and smaller, your case will not necessarily hold a bigger power supply. So a lot of times you'll have to buy a power supply that'll fit within the confines of the space left for it. You're also going to want to look at how many different types of power cord attachments do you need? How many things inside your computer need to be attached to that power supply easily? So you're going to have to find a power supply that has the different wires and cords to supply power to the motherboard, to supply power to the drives, to whatever else is in there. So let's determine specific requirements simply based on the internals. For this, I'm actually going to use Newegg. So I put down here, I got a 2 gigabyte DDR2, it's actually 3 RAM computer. So I like the Newegg site because, and it's better than it was last year, is it tells you the wattage requirements. So first of all, we're going to go to our central processing. Now, the computers we're playing with in class have Intel ES6300. Where are they at there? I'm not at S's. Maybe. Did I pass it? Core Dual. There we are. It's not ES. It's E6300s. So that's our first one. Our motherboard, we're going to pick an ATX. We actually have a BTX, which is a modified ATX made specifically for Dell. The ATX, you'll almost never go wrong because that's going to be probably your biggest draw on power. So the computers we have in the classroom have actually no GPU. They don't have any fancy graphics processing unit. It's just built onto the motherboard. For RAM, we have like the lowest amount we can get, which is 2 gigabytes. They don't even DDR3. That is the least amount we got. For solid state drives, these computers don't have solid state drives. If they did, I'd steal them probably. But we do have hard disk drives running 7,200 RPMs at 3.5 inch, and we do have a CD-ROM drive. So my doing all this with is pretty simple. Uh, got me to 171 watts. So right now, with nothing added to it, I need 171 watts. Before you go and buy a power supply that meets the bare requirement, remember that if you're building a computer yourself, you might want to expand the computer and add things on. If you buy a power supply that's just barely meeting it, you're going to have to buy a new power supply. If you're picking up someone's computer and you notice that their power supply barely meets the requirements, adding just a few extra things to that power supply, whether it's coming in off USB and you're using that USB to run it or something else, could take that, push it over. So, how much does ours use? It says 171 watts. That's what we need. Does our power supply in our computer meet those requirements? For this, I actually am going to go to Amazon Play page. As I've told you in other classes, one of the easiest ways to find parts is to take that current part, take that part number, and look it up on Amazon. So this is actually the replacement. The ones we have in class are much older than this. So the ones we have in class are actually 235 watts, but they don't make that model anymore. When you're reading the back, it's funny. Each of these out, even by the same company, each of these cards reads a little differently. What you're going to have to find is output wattage. In this point, they have a lot of stuff, but our output wattage is right here at 255 watts. So not to exceed 255 watts literally means you can't put too much more on it. So does our meter requirement? Yeah, we had a 71 watt requirement. We have a 235. I told you ours is older. But even on the newer ones, 255 watts, we can meet it. Now, here's another one of those things when you're thinking about computers. Now, ours, the ones we're using in class really are like this, and they're a stacked design, this weird, odd box thing that's pretty unique to that Dell. That creates a problem in that buying a replacement pretty much limits you to a very few options. And you have to make sure that it'll fit in the space given inside the computer. In this case, it will not hold that square because other components impede upon this. It's actually the DVD drive that impedes on this space that they've cut away from this power supply. Um, so let's go back to the very last question. And I'm going to go to the back. On most power supplies, and this is not ours, it's just one I found. There's a ton of these. This one actually has the warning label and it's upside down. On most power supplies, there's a little switch in the back here that says 115 volts. It has another option, and the reason it's so hard to switch is because these power supplies have been designed to work both in the United States and Europe. If you switch this, you'll get the voltage for Europe. And if you do that and plug it into an American system, pretty soon you will burn up your power supply or vice versa. So this little switch, take a look. If you walk up to a computer, somebody says it had problems and it smells like ozone, that means they've been burning electricity. Look in the back and see if somebody stupidly switched this switch thinking that they increased the power of their power supply. I've heard somebody say that before. It doesn't increase the power, it just changes what it inputs and it pretty much fries it out. So that completes our power supply. If you want more stuff, I use the Newegg computer because I like it. Computer Hope is a great place to go and get stuff in really normal person speak as opposed to high end geek speak. I hope that helped.